Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. Here question is design DFA that accept all strings where length of the string should be divisible by 2 or we can say even length string. As we know that any number if it is divisible by 2 that number is called as an even number. So here even length string this is same as string whose length is divisible by 2. So first try to identify the condition, try to understand it and accordingly write down the minimum length string set. Here condition says that all the strings whose length should be divisible by 2. So first what are the numbers which are divisible by 2 or what are the even numbers? So 2 is a even number, 4 is a even number or 6, even 0 is also even number. If 0 divisible by 2, yes, if 0 divided by 2 we are getting remainder as a 0 only. Then based on the length of the strings where 0 or 2 or 4 or 6, write down the minimum length strings. So what are the strings having such kind of length? For example, what are the strings whose length is 0? We have epsilon. Epsilon is an empty string whose length is 0. If sigma contains a comma b, then what are the strings whose length is 2? For example, double a or I can say double b or any combination of a and b. What are the strings whose length is 4? I can say 4a's or I can say 4b's or any combination of a and b. Similarly, we can write down the 6 length string. Once we have written the minimum length string set, we can design DFA for this. As we know, automata consists of various states and states are represented by circle. So first state is Q0. Whenever epsilon is a part of minimum length string set, your starting state becomes the final state. Reason behind this I have explained in my previous videos. So epsilon is getting accepted here. Next string double a should get accepted. It means what? After reading this double a, automata should enter into final state. So start designing DFA for this double a. Our state is Q0. As we know, one state read one symbol at a time. So first a will be read by the Q0. So we are writing transition for the first a from the state Q0. Single a should not get accepted, hence transition for the single a should reach out to non-final state. Second a should get accepted because length of the complete string is 2, it is even. So second a transition should reach out to final state. So transition from this Q1 should reach out to final state. So instead of creating the new final state, we have existing final state. We can connect transition of the second a from Q1 to the Q0. There might be question in your mind why we are not creating the new final state, because we are utilizing the existing final state, hence we are connecting transition of second a to the Q0 unless and until it's not reading any invalid string. In this case, this transition is not reading any invalid string. How to verify it? For example, triple a should not get accepted because length of this triple a is 3. It should not get accepted. If you want to check, we can verify it. First symbol will be read by the Q0. Automata starts with the Q0. First symbol is A. Automata reaching to Q1. So Q1 will be reading the second symbol, that is A. Q1 reading the second symbol A. Automata reach to state Q0. Q0 will be reading the third symbol. Q0 reading the third symbol A. Automata reach to state Q1. Our string is completed. Where is automata? Automata is in the state Q1. Q1 is a non-final. Hence, triple A is not getting accepted. Hence, transition from Q1 for the symbol A is correct one. Now, next string, I can take double B, I can take AB. Any two length string. Suppose if I take double B should get accepted because length of the string is 2. It's even number. Hence, double B should get accepted. So first symbol, first state, first symbol is B, first state is Q0. So transition for B from the Q0, we can write like this. We can utilize the existing transition. How to read this? Q0 can read A or it can read B, reaching to state Q1. So Q1 will be reading the second B. And transition for the second B should go to the final state because length of the string is 2. Hence transition for the second B should reach out to final state. So from Q1 already there is one transition for A that's going to the final state. We can utilize this. I can write like this, A or B. How to read this? You can read in this way. Transition from Q1 reading A or reading B. Hence double B also gets accepted as it's going to the final state. If we want to take AB, we can design DFA for AB also. First symbol is A. Automata starts with Q0. Q0 is reading A. There is a transition for A. So Q0 reading A and going to which state? Q1. Q1 reading the second symbol B. Q1, there is a transition for B also. So Q1 reading B going to state Q0. Our string is completed. Where is automata? Automata is in the state Q0. Q0 is a final state. As string is completed, automata is in final state, hence we can say AB is accepted. Similarly, it can be checked for BA also. First symbol B, second symbol A. It can be checked for any 4-length string like AB. First symbol A, second symbol B, third symbol A, fourth symbol B. Automata is reaching to Q0. Q0 is our final state. Hence AB also gets accepted. Hence this is final DFA. But as a last step, always check whether design DFA is deterministic or not. What is deterministic? Deterministic says that for each symbol of sigma, there must be only one transition from each state. In this case, from Q0 there is a transition for A as well as transition for B. From Q1 there is a transition for A as well as transition for B. Hence this automata is deterministic, and this becomes answer of given question. You can practice similar kind of question where sigma is 0, 1. In the next session, we will be learning how to design DFA where length of the string is divisible by 3. Thank you for watching.